Welcome, Bearcats and parents. On tomorrow, we have our Chapter 2 test on equivalent rational numbers. I wanted to take a few minutes to look at our unit test review or study guide and go over some of the most commonly missed questions or problems that I saw today in class, just in case you did not get a deeper understanding of why that may have been the reason or way that that problem should have been worked. So let's go ahead and jump right in. We're going to start with problem number 2. Problem number 2 says CJ and his team wanted to determine how many players rode the bus in high school. The survey results showed that 9 out of 24 players rode the bus to high school, represented as a decimal. What part of CJ's team rode the bus? So first of all, 9 out of 24 is a fraction. So I'm going to put 9 over 24. We need to change this fraction to a decimal. So I'm going to pull out my foldable and I'm going to say, how do I go from a fraction to a decimal? According to my foldable, it says divide the numerator by the denominator. Again, this is what we call Tybo. So I'm going to use Tybo, top in, bottom out. So my top number is 20, saying it backwards. Top number is 9. My bottom number is 24. I know that 24 cannot go into 9. I'm going to add a decimal and 2 zeros and bring my decimal point up. I'm going to pull out my handy dandy card and help me remember my division process. First of all, how many times can 4 go into 9? 0 times. Slide my card over. How many times will 24 go into 90? I know that 24 times 2 would give me 48. So I'm sure I can probably double that. And I do a little side work and I figure out that is 3. 3 times 24 is going to give me 72. Please make sure when you are subtracting that you regroup. I need to borrow and cross this out. This will become 8. 10 minus 2 is 8. 8 minus 7 is 1. Then I'm going to check my answer. Is 18 less than 24? Yes. Check off my 3. Slide my card over. I'm going to bring down my 0. Now, how many times can 24 go into 180? Again, I do some side work and I figure out that 7 times 24 will give me 168. I subtract. Remember to regroup. This becomes a 7. This is a 10. 10 minus 8 is 2. 7 minus 6 is 1. Is 12 less than 24? Yes, I check off my 7. Slide my paper over. I need to add a 0 so I can bring it down and finish off my problem. How many times will 24 go into 120? Side work is done. I figured out 5. 5 times 24 will give me 120. I subtract. I get 0. 0 is less than 24. Check off my 5. I am done with this problem. Please remember, decimals are going to do one of two things. They're going to repeat or they're going to terminate. This is a terminating decimal. It comes to an end. So I'm going to keep working it until I see it ends or I see it repeats. This is the answer we have to put into our griddable. As you notice, we only have 2 places. So I'm going to round it to the nearest hundredths place. The 5 will tell me what to do to this 7. Remember, if it's 5 or more, raise the score. 4 or less, I let that number in the hundredths place rest. So this 5 is going to tell me to raise this 7 to an 8. So in my answer, I'm going to write 38 hundredths. That would be the final answer that would go into my griddable. Please make sure you're practicing the skills with the griddable. The next one, let's look at problem number 3. Problem number 3 said that the coach found that 62.5% of the players exceeded their minimum, which represents the part of the players who did exceed their minimum. 62.5%. The first thing I want to do is change this fractional part to a decimal. So I look on my blue chart. And on my blue chart, I find that 1/2 is 5/10. So I'm going to change that 1/2 to 5/10. 62 and 5/10, and that is still a percent. I did not do any conversion. I did not change anything. I just made it from a fraction to a decimal. Then I need to figure out, how do I go from a percent to a decimal? From a percent to a decimal, on my foldable, it says that I will remove the percent sign and move the decimal 2 places to the left, So I'm going to remove my percent sign and move my decimal 2 places, 1 place, 2 places to the left. So as a decimal, this would be 625 thousandths. This 5 is in the thousandths place. And I start looking at my answers. Are these two the same? No, this is 625 10,000ths. This is not right. Is this the same? This is 25 and 5/10, but this is not in decimal form. That is not correct. 7/9. If I divide this by doing Tybo, I'm going to get 7, 7, something repeating. That is not it. 625 thousandths, 625 thousandths. These are the same. If I took this decimal and wrote it as a fraction, I would select or write it as it is written in B. That is the correct answer. Number 4. Will Fuller saved $45 to spend on a new outfit for his upcoming game. He bought a jacket for $15. So this is important information, which shows the part of his savings Will spent on the sweater. Should say jacket or jacket. We make mistakes. Next year we'll correct this. So whenever you are talking about a piece or a part of the whole thing. Remember, a fraction is a part of a whole. When I talk about 2/3, that means it's 2 out of 3. So Will Fuller spent 15 out of 45. So 15 of the dollars he spent on the jacket out of the 45 total dollars, that is a fraction, a part of the whole thing. So you're going to set this up as a fraction. Remember, it's the part over the whole. Part of the whole thing. Part of a whole. 15 over 45, I'm going to simplify it. You can do your factor trees and find the GCF, or you can just find a common factor, whatever works for you. So I'm going to go with 15. 15 will go into 15 one time. 15 will go into 45 3 times. 1/3 is how much he spent on the jacket. It's not 1/2. 1/3. Let's look at my blue chart. 1/3 is 33 hundredths, or 33.3%, or 33 1/3%. Not 30%, 3/5. No, it is 33 1/3%. So this is our answer. Let's look quickly at number 6. We want to make sure that everybody understands how to model for our test tomorrow. Show 4/5 on of each model. Again, 4/5 on my blue chart is 8/10 or 80%. So I need to know this information. 8/10 or 80%. So this is a tape diagram. It's broken up into 10 boxes, and I know each box represents 10%. So if I want to model 80%, I'm going to color in or shade in 8 of those boxes out of the total 10, and that is 80%. On my number line, I'm going to move my 1 hole here. If I was placing 8/10 or 80 hundredths on a number line, where would I place it? It would actually fall about here. So I would imagine, let's say this is half, 50% or 50 hundredths. 80 would be a little bit maybe closer to 1, a little bit over, but it would be closer to 1 whole. So about there we can say. And on a 10 by 10 grid or a 100 grid, I would shade in 80 of these squares, or I could shade in 8 rods of 10 to represent my 800ths or my 80 hundredths. So this is how you would model 4/5 on a tape diagram with a number line and with a 10 by 10 grid. Let's do one more problem. Let's take a look at number 9, maybe 2 more problems. Number 9, K.J. Dillon correctly performed 92% of the plays. What fraction? So I want to make this a fraction. Again, 92%. Pull out my foldable. I hope you're using it to study. How do I go from a percent to a fraction? Write the percent, which means out of 100, over 100. You're always going to write the percent over 100 because percent means out of 100 or per 100 without the percent sign. And don't forget to simplify. So let's put 92 over 100. And then we have to think of some simplifying, the GCF or a common factor, a CF that we can use. I know that it's divisible by 2, but I'm also going to look at my answer choices, and I know it can either be divided by 5, which 92 cannot, to get 20, or 25 I can divide by 4. So I'm going to use my answers to guide me with my simplifying. How many times will 4 go into 92? You can do a little side work. You will get 23. And I know that 4 times 25 will give me 100. So 23 over 25 will be my final answer. I wanted to bring attention to number 10. Please remember the capital N-O-T means that 3 of them are going to check off right and 1 of them is going to be wrong. You're looking for the one that is wrong. So this one is 7/10. How would you make this a fraction? You would write it as, just like you said, 7 over 10. How would you make this a percent? 2 places to the right, it would be 70, and then I'm just going to use this as a percent sign. You would move it 2 places to the right. So then you start checking to see which of these will check off. 70% will check off. Is 70 hundredths the same as 7/10? Yes, it is. You can always add or remove zeros at the end as needed. It would represent the same amount in a 10 by 10 grid, so this will check off. What about 14 over 20? What can I do to get 14 over 20? If I took 7/10 and multiplied it by 2, I would get 14 over 20. So this checks off. So 3 are checked off, 3 are right, and I'm looking for the one that's wrong. 70% and 7% are not the same, so this is the one that's wrong. Again, please pay attention to the capital N-O-T. Let's go down to number 12. It says Shane had played 50 games in 3. That number in word form of the games he was injured during the play. Which decimal represents the part of the games in which Shane was injured? Well, he was injured in 3 out of 50 games. 3 out of 50 games. Remember when I told you the part out of the whole thing? The part he was injured was 3 and the whole thing was 50 games. So you want to change 3 over 50 to a decimal. Again, you can use Tybo and divide, or you can use what Ms. Jackson told you on last week. If it is a factor of 100, if it's a 2, a 4, a 20, a 5, a 25, those numbers of 50, and you can make it into 100, just make a new equivalent fraction over 100, and that's less work than trying to divide. I know that 2 times 50 will give me 100, so 3 times 50 will give times 2 will give me 6. So 6 hundredths. 6 hundredths. That's a quick, easy way to get your